Well then, it's time for the Daily Space Weather. And thanks for tuning in to the Smash News Network, least busted name in news. I'm your host, Dan, a.k.a. Smash-O-Mash, coming at you once again with only the most comprehensive daily space weather and imagery of the sun you'll find in the known universe. This goes our 195 angstroms wavelength, just a spectacular wavelength. To view the closest star, it's the past 24 hours, and here we've added 304 angstroms to give some additional contrast to the massive number of filaments that are on the earthly facing portion of the solar disk. Some of them have been named after humans, living people, like the Shack filament, the David Lee Roth, the Bill Gates, and the Klaus Schwab filament. Yeah, if you want to name filaments, join us over on Twitter and follow the hashtag #NameThatFilament. Now, we're going to talk about planetary alignments for a brief moment. Some fascinating information about Earth's low velocity and ultra low velocity zones as well. So we've got this new sunspot. I don't memorize the names because that's useless information. That is the most magnetically complex region for the solar photosphere. You're actually looking at the corona in this imagery. Here's a close-up of that sunspot. And of course, we've also got this sunspot setting over here in the southwest. So the southeast and southwest are by far the most likely places to see large solar flares in the next 24 hours. You can see some flaring there. Those are plasma filaments splashing back down toward the chromosphere. And that's a special type of flare as that plasma reintegrates to lower altitudes in the solar atmosphere. Again, lots of filaments. Likelihood of coronal mass ejections really high, and we've seen a massive number of coronal mass ejections. They almost all came out of the southeastern limb yesterday. And last but not least, we do have another active region rising back here behind the northeastern limb, and we may indeed see a sunspot rising there. Let's take a look at the raw sunspot view here from the SDO. So this sunspot, it's actually degraded a little bit since yesterday. It's shrunk, in other words. And this one has grown in terms of sunspot number because more sunspots have risen. So this is the most magnetically complex sunspot for sure, although the likelihood of large flares, again, does indeed exist both here on the southwest and over here on the southeastern limb. Here's a colorized magnetogram from SDO to show you more active regions. You can see some active regions in the north there. At the moment, no sunspots in the northern hemisphere. And let's talk about the merch. Yeah, the merch. If you haven't checked it out, you can find links below the video as well as on the homepage at smashomash.com. Today's featured merch is our third top seller, actually, Mensa, which stands for Make Earth Not Suck Again, as there are plenty of bureaucrats and even YouTube content creators that are doing their part to make Earth suck. One of the goals of our channel is to make Earth not suck again. Of course, it's just a ribbing on certain popular mottos, certain slogans that you may be familiar with. And by the way, the channel is completely apolitical. I've never been associated with a political party, and I probably never will be associated with a political party. My views are way too nuanced. So you're invited to Mensa, Make Earth Not Suck Again. And if you're an international viewer, we've shipped these as far away as to Tasmania. Let's take a look at what's going on in terms of volcanoes. And we do indeed have some volcanic eruptions, starting with Shiveluch, which is producing a 13,000-foot ash plume as it explodes. Flight level 130 over Kamchatka from Shiveluch. Flight level 200 over Bezimiany. So it looks like an uptick there at Bezimiany. 20,000-foot ash plume as Bezimiany also explodes. 6,000-foot ash plume over Subanose-jima. 7,000-foot ash plume over Dukono as it explodes. Popocatépetl likewise exploding, producing a 25,000-foot cone of volcanic ash. Please do not pole vault the caldera. It's a flight level 250 over central Mexico. Headed down to Central America, Fuego in Guatemala exploding, flight level 150. Nevado de Ruiz exploding in Colombia, flight level 210. Not observed in Ecuador. So Ecuador has calmed down here. We've seen as many as 3 volcanoes going off at the same time. At the moment, Cotopaxi is the only one on the list, but volcanic ash not observed in imagery. And Sabancaya exploding in Peru, flight level 220. It's a 22,000-foot ash plume. And let's take a look at seismicity. We've got a fascinating story to share with you today. Also, here's your 90-day graph of seismicity on a global scale. And let's see what's been shaken. Well, we will see what's been shaken in the past 24 in a minute. First, let's talk about this article. So this map right here is going to show you the ultra-low velocity zones. Those are the orange regions. And then there are various different possible ultra-low velocity zones. The pink regions are low velocity zones. And these are areas where seismic waves pass through the planet differently at different speeds. So it gives us insight into the internal structures within the Earth. And you can find this great story here on SciTech Daily. So the title is Seismic Sleuths Reveal Earth's Secret Mountains, as the core mantle boundary is sort of part of the unseen portion of the planet. It is not just a plain old sphere down there. It's croissant-shaped. Oh, just kidding, folks. Anyway, an interesting article there, and it does link to the full paper at the bottom of the article. I'll briefly scroll it here. And again, the link is right down at the bottom of the article. It'll link you to this paper. Globally distributed subducted materials along the Earth's core mantle boundary, implications for ultra-low velocity zones. Anyway, here's what's going on as far as earthquakes in the past 24. We'll report quakes over a 5 magnitude, and I think there was only one quake of a 5 magnitude or higher. So just a quick reminder that any earthquake can be a foreshock. So if you have had an earthquake in your area, please be prepared for the possibility of a larger quake in that same location or nearby. Largest quake of the past 24 was a 5.8 south of Kamchatka. That happened at 2:22 Universal Time this morning. So there's the rest of the list, and let's get back to space with a 24-hour 171 angstroms wavelength view. And we'll also add, here's 284 angstroms along with 171 to add a little bit of additional detail there to the corona. And let's talk stats. The 10.7 centimeter radio flux is now still at 137 solar flux units. So a bit of a leveling off there in the radio flux. And we'll see the sunspot number rise a little bit today as some new umbrae have risen in the southeast behind that new magnetically complex sunspot, the area where all the coronal mass ejections have been coming from. Space Weather Enthusiast Dashboard, which is NOAA's forecast, is not forecasting any geomagnetic unrest or geomagnetic storm conditions. Things are calm in the space between the Earth and the Sun. Here's the past 4 hours of Earth's magnetic moment from space. We show it daily on the channel as the data is not yet accessible in archival format. So we show 4 hours a day. Again, things are geomagnetically calm here at the moment. This imagery depicts magnetohydrodynamic pressure, the units of which are nanopascals. Earth's magnetic moment from the ground looks thusly for the past 4 hours. And thanks for leaving comments, Mike Bordages. Again, that's the last 4 hours of Earth's magnetic moment from the ground. This will show you the most likely places to see the aurorae, also pipeline, railway, and power grid induction, the telluric currents of planet Earth. Next, the Planetary K-index, which is a general global geomagnetism index. KP2 is the current situation. Planetary K-index at 2. Again, geomagnetically calm conditions. And let's look at the real-time solar wind, which is dropping down a little bit here again today. Current conditions are actually a little higher than yesterday's video, 412 kilometers per second. Solar wind density here quite low, about 1.5 protons per cubic centimeter. That is indeed quite diffuse. Let's move on to some magnetic data. our GOES magnetometers from their geosynchronous near equatorial orbits are reporting these figures for the past 3 days. And let's take a look at the heliospheric current sheet next. So Earth has recently entered a North Pole current sheet. At the moment, the South Pole current sheet is much larger than the North Pole current sheet. I mean, this is partially because there's so much North Pole magnetism still at the North Heliographic Pole, which you can see right here, that huge green blob there. That's a coronal hole at the North Heliographic Pole. So that needs to leave the North Heliographic Pole. And also this red area, there's significant South Pole magnetism at the South Heliographic Pole. And you can see there is some red magnetism here, some South Pole magnetism at the North Pole. But the main thing is this large blob of South Pole magnetism on the opposite side. Top view ecliptic plane field plot is a great data set if you understand how to read the data. Next, our line of sight field plot depicting the solar B field in blue, solar polar fields in green for north and red for south. And let's move to coronal holes next. So there is the coronal hole view. We've got North Pole oriented coronal holes rotating in here, and let me just bring up that imagery from SDO. So there's the latest image from the line of sight coronal hole plot, part of the National Solar Observatory, and here is 211 angstroms. All right, so we can expect to see a high-speed coronal hole wind stream in about 4 days, I'll say, from this coronal hole right here. We've got some more coronal holes getting more well-defined as we forecasted yesterday. And let's move to sunspots next, which is pretty weak, really. Okay, looks like we have a... Anyway, we're going to have a higher sunspot number today. Likelihood of large flares is actually kind of high because both 3270 and 3272 are both magnetically complex enough to produce large flares, and they are both close to the limb. So that's the situation for sunspots. Here's our SDO intensity gram, and let's zoom in. That is yesterday plus today's data, by the way. Not a whole lot of evolution of those sunspots. And let's move to energetic particles and solar flares. So no relativistic particles. The proton flux remains flatlined here. Also no major flares, only flares of a C-class variety, at least up until yesterday around 5:50. We covered that one. See yesterday's daily space weather video for some great close-ups of that M-class solar flare. Meanwhile, the X-ray background has gone up a little bit in the past day. Let's take a look at some imagery. There's the GOES R131 plus 94 angstroms wavelengths. And let's subtract 94 angstroms to show just 131. And it's almost time to talk about things like planetary alignments. So let's take a step back and take note of where things are located. An act in space known as astrography. Yeah, astrography. So this is what's going on overhead over Lehigh Valley. I'll press the Now button here from skyandtelescope.org's star chart. You might see Jupiter and the Sun getting very close together in the sky. That's causing people to become frightened of things that are not any sort of an actual risk. So let's talk about planetary alignments here. You can see how closely aligned Earth and Jupiter are. We've been seeing it get closer and closer on the Soho-Lasco C3. Let's do a solar system forecast. There's where things will be in 1 week on April 14th. So let's talk about planetary alignments, and let us know in the comments if you think planetary alignments cause natural disasters and or solar activity, as I've heard people just spouting nonsense about it for years and years. You may remember in 2020, Saturn and Jupiter were aligned in, I believe it was the month of May, or it was either May or June. And Earth went right past the nearly perfectly aligned Saturn and Jupiter and made a line between Jupiter, Saturn, the Earth, and the Sun. A lot of people forecasted a magnitude 15 earthquake, or solar flares, or a grand solar minimum, or who knows what they forecasted. They forecasted all kinds of things that never came to fruition. And they just continued on after nothing happened, like nothing happened, because nothing happened, and then they don't admit that they're wrong, and that's the way things work on YouTube. Anyway, here's an article from Time Magazine, and I'm not an endorser of Time Magazine. It's pretty much a toilet paper factory, but here are some facts. The sun's gravity on Earth, its so-called tidal force, is 1.0, and then the moon's tidal force would be 2.1. Venus's tidal force would be 0.000113, and Jupiter, despite being so massive, tidal force would only be 0.0000131. So there's an article that just came out a couple days ago on the 29th of March from Time Magazine, and there we'll briefly show it. The persistent myth about planetary alignments. It goes on and on and on. And no, I don't think planetary alignments do jack. Many people will tell you that, but the Earth doesn't really orbit the Sun. The Sun orbits the barycenter, which is the gravitational center of the solar system, which is entirely true, but it doesn't cause anything to it doesn't control the solar activity. It doesn't control Earth's activity. It's just a complete ridiculous myth. So let's look at some coronagraphs. Here are yesterday's data, and look at all the CMEs coming out of the southeastern limb. Just repeated CMEs from the southeast, and those do not appear to have any earthly directed components. That's 105 frames from yesterday. Here are an additional 28 frames from today. And by the way, there is a CME kicking off in the northwestern limb. We don't expect that to be earthly directed either. We'll talk about it here in a minute, right after we look at the view from Stereo A, located right there, and the Soho Lascaux C3, located at Lagrangian point 1. So again, a very large number of CMEs happening. This helmet streamer up here by my pointer is currently ejecting while we stream the video, and the likelihood of this one ejecting is very high as well. So that's something to keep an eye on. And when I say eye on, well, pardon the pun. Don't worry, we've got some spectacular 24-hour videos as well. Just a lot of material coming out of the southeastern limb. And here's one of our 24-hour videos. Let's get a little bit closer. And thanks for leaving a comment, Mr. LaFollette. So that's the situation. Those CMEs are not earthly directed. And let's take a look at the filaments. And there are a massive number of filaments indeed. So this is the David Lee Roth. Down here you've got the Shaq, which looks like it's ejected. That's the Shaquille O'Neal filament, and I think it's actually collapsed. Here's the Bill Gates filament. And last but not least, we've got the Klaus Schwab filament. If you want to name more, like this one up here could use a name. That's certainly a significant one indeed. You can join us on Twitter. Just follow the hashtag #NameThatFilament, and you'll see our previously named filaments. Interestingly enough, the Tamitha Skov filament actually caused quite a significant geomagnetic storm when it ejected and struck Earth's magnetosphere. Here's another 24-hour video. And once again, thanks for stargazing with us here at the Smash News Network, least busted name in news. 284 angstroms is a wavelength not even covered by the SDO, but it is covered by the GOES-R. And here is the GOES-16 SUVI. This is only the past about 2.5 hours. Again, there is a CME erupting happening, a coronal mass ejection happening right now. You can see this huge prominence coming up here. And actually, that looks like it may be curling around this way. So that could collapse back down to the sun. It could eject in this direction. It could eject most likely off to the northwest. Or it could just collapse and cause a flare when it strikes back down toward the chromosphere. We'll stream it to show its evolution throughout the day today on the Twitch channel. And we like to use Twitch to live stream because it is so good. It's quite good. Quite good indeed. So this brings us to our bonus features segment. Let's talk about satellite charging hazards first. We do have some minor surface charging hazards here on the outsides of satellites. That's caused by low energy electrons. Those are moving into the equatorial Pacific in the northern portion of the Pacific Ocean. Here is our GOES electron flux. That is the free electrons at the F layer of the ionosphere as measured by the GOES-16 and GOES-18. And I believe my forecast was right on. Go watch yesterday's space weather video. I think that's almost exactly where I put my forecast. Just a little bit higher than NOAA's. The green boxes are the forecast. The yellow diamonds are the observation. We'll show a one-year chart also. There is the one-year chart to put all of that into context. We're in moderate to high levels of electron flux. And since that's measured at the F layer of the ionosphere, feel free to pause the video on this frame if you're not familiar with electromagnetic radiation penetration, chemical concentrations, and temperatures of the thermosphere especially. Here is the F layer, and I'm seeing lots of high-frequency anomalies for sure. So this could lead to things like rapid stratospheric heating effects. It looks like fairly high-frequency anomalies here. Anyway, if you're not familiar with looking at this data, don't worry. We'll show the anomalygram once this plays through. So here's the anomaly in megahertz from the 30-day median. Some major low-frequency anomalies happening there also, shown in red. Looks like we've got mainly low-frequency anomalies here. Anyway, things are looking pretty heavy in the ionosphere. Here's the latest image. That's 11:30 Universal Time ionogram and 11:30 Universal Time anomalygram. We'll also show the total electron content forecast. It's the free electrons up to about 12,500 miles. Feel free to pause the video on this frame if you're not familiar with the distances to various objects and the Van Allen belts, for example, in miles. Here is the total electron content forecast. It does endeavor to provide a 30-minute forecast on the electron content. And if your GPS is not anticipated to be accurate, try turning on Wi-Fi accuracy. Sometimes that'll help you. If there are Wi-Fi hotspots, their IP addresses may be used as their locations are known, and they can help you navigate. Here's the 10-day average, the anomaly from 10-day average, rather, for the total electron content over North America. Nothing to write home about going on there. Last but not least, we'll look at some high-res images to check out the magnetic fields. We do have a sunspot up there yet, but it's not very complex. That one there has been spreading apart here for a few days. It is still beta gamma class. As far as beta gamma delta class, it's not really. More just beta gamma class, in my humble opinion. And this sunspot is the most magnetically complex sunspot. It's actually looking a little bit more chaotic than it did when I first woke up this morning. So there are the magnetic fields. It is beta gamma delta class. Quite a bit of complexity there. Those are like what you would call unsustainably complex magnetic fields. Anyway, here's the full disk rock back. Oh, wait a minute. Do we have a new sunspot rising? Certainly not yet. Just a plage up there, a bit of an active region. There's your full disk rock back. And that brings us to our meteorology segment. And we're starting things out looking at nullschool.net's view from space. There's the space view. These are the likely auroral ovals. Again, geomagnetically calm conditions here, so no major aurora are likely. Just sort of the normal spots where you'd expect to see the aurora. Anyway, let's move on to surface winds. There you go, surface winds of that side of the planet, jet streams of this side of the planet. There's a divergence happening in the western Pacific, and a convergence happening in Southeast Asia. Here are the jets of the Americas. Huge stretch of backward jet stream here over the central Atlantic, and a huge bend over the Caribbean. So some huge bends there in the jet stream in the northern hemisphere indeed. Also some chaos in the southern hemisphere jet streams. Here are the surface winds of this side of the planet. Surface winds of the central world. Turbulent water there is between Africa and the Southern Ocean. And last but not least, the jet streams. We'll show clouds and fog over the Americas next, and be prepared for massive flooding. If you're downhill from record snowpack, your hydrologic output is flooding. And there are huge sections of the U.S. that are under a hydrologic outlook watch. That's caused by snowmelt. And if the temperatures rapidly rise, the water will rapidly fall. So here's your weather.gov map, and you can see all of these green areas. Those are hydrologic output. That is from snowpack melting. And again, expect to see some epic meltwater following a seventh consecutive epic year of record snowfall in the northern hemisphere. So that's your weather.gov map. If your location's lit, click your location. We showed the key. That's too many counties to cover, so let's take a look at some forecasts for the lower 48. This is your temperature anomaly forecast. So you can see some very high temperatures rolling in here. In the next 3 days, that's a GFS 72-hour temperature anomaly forecast in degrees Celsius. And many places are going to experience some shocking amounts of snowmelt. Now, we as bicyclists are not fans of that because we don't like to ride on wet roads. Although we do like to ride around snowbanks, so it's a double-edged sword there. Riding up hills that have snow on the side of them on warm days is just super cool. Anyway, here's your 72-hour GFS pressure and precipitation forecast. And you can see some additional snow continuing to fall on California and parts of the Pacific Northwest. and generally the northwestern Rockies. Here is your GFS 72-hour positive accumulated snow depth change in inches. Some heavy snows there forecasted for northern Wisconsin. Looking like an additional 8 inches coming there. Let's take a look at the Euro forecast versus the GFS forecast. There's the Euro forecast, very similar. And there's the GFS forecast, just shifting that a little bit to the northwest of the Euro forecast. So, yeah. That's what's up. Windy.com. They've got a free mobile app. Perhaps check that out. We just tell you this because we're looking out for you, the viewer, and not providing you with a bunch of nonsense. Check out the lightning mapper. Dag, there is some crazy lightning here around the Texas Gulf Coast especially, and it's continuing. Also, some directed energy weapons here over southern Colorado. Look at that. Oh my God. Directed energy weapons, folks. Are you spooked? Check it out. Here it is. Oh, nose right there. Look at, oh my God. It must be the government. It's a directed, it's Project Bluebeam or something. Pardon my sarcasm. Here is your current lightning map from lightningmaps.org. It looks like things have actually calmed down here around the Texas Gulf Coast, although we still do have some active cells, both south and east of Houston. Might be some good surf on the Gulf Coast here at the moment, so break out your wetsuit. Your likelihood of getting bitten by a great white shark is kind of low in the Gulf. Anyway, quite a bit of lightning here around the U.S. And it looks like it's making its way up toward Baton Rouge. Hey, Beaumont. There's thunder rolling in. And we're going to close this thing out. First, again, please visit our links. Support the channel via your Hemp Lucid purchases. If you're already shopping at Hemp Lucid, why not enter the promo code SMASHOMASH and save some dough on checkout? SMASHOMASH is the promo code to use. You can find links below this video as well as on our homepage to all of those splentacular products from Hemp Lucid. And again, don't forget to help us out with clicks. So if you're unable or unwilling to open your cobweb-encrusted wallet, help us out with clicks. Visit us on social media. If you want to see things about fitness and lifestyle and diet, hit us up on Instagram. I put up a lengthy post about training just a couple of days ago. If you're interested in getting in better shape and your diet and things like that, we talk about it regularly on Instagram, all over the internet at SmashoMash. We'll close out today's video with the U.S. Doppler radar. Quite a bit of precipitation here across the lower 48. We'll also show clouds and fog using the 3.9 nanometer infrared radiation map. And also the ever popular, we love it, the 6.19 nanometer radiation map, which shows the water vapor, like all of the water vapor. So if your Doppler is not clear, this should help to clear things up. And we've got this atmospheric river coming up here and kind of making a right as it collides with a bunch of dry, massive air from Canada. That is a relative high pressure zone right there, as colder air is more massive than warmer air and drier air is more massive than moister air. Anyway, here's your recap to close out the video. U.S. Doppler radar. Clouds and fog from the satellite's perspective. And water vapor also from the satellite's perspective. Hopefully you've got perspective on things like space and Earth weather and you're able to forecast your own. Thanks for tuning in. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off, and may that solar wind be at your back.